your podcast on the acid hydrolysis of esters. All right, so acid hydrolysis of esters is essentially the opposite of esterification. So remember that esterification is where we form an ester from a carboxylic acid and an alcohol. And in acid hydrolysis, we're actually going to break that ester linkage exactly where we formed it. So think of it as the reverse. It will reproduce an alcohol and a carboxylic acid. And this reaction is going to require, obviously, an acid catalyst because it's acid hydrolysis. And it's also going to require water. So think about the word hydrolysis. Hydrolysis is using water to break apart. So we're going to use water and acid to break apart the ester bond. Okay, so let's take a look at our example. We are starting with ethyl ethanoate. And we're in the presence of a random acid. We don't know which one, so we just put a proton on there. And water. So I've drawn these out kind of funny, showing the bond lines here because we have a lot going on. We are going to break the ester bond between the single oxygen and the carbonyl carbon, just like where we formed the ester bond. So this alcohol, when it comes off, will look like this. Okay, the hydrogen from the water is going to bond to the oxygen, reforming an alcohol. And this OH group is going to bond to the carbon in the carbonyl, reforming our carboxylic acid. Okay, so the OH came from the water, the H came from the water. We reform our carboxylic acid and our alcohol, and let's go ahead and name those for practice. So we have a 2-carbon carboxylic acid, that is ethanoic acid, and we have a 2-carbon alcohol, that is ethanol. Practice with a word equation. We have propyl benzoate is hydrolyzed in the presence of an acid. Okay, so propyl benzoate, that tells us that we started with benzoic acid, so we have an aromatic. Okay, so that is a benzene ring with an ester coming off. So there's our ester, and we know that the alcohol that was involved is a 3-carbon alcohol that formed this ester bond. Propyl is a 3-carbon alkyl group. And I am going to draw my water the same way that we drew it in the last example. And that is hydrolyzed in the presence of an acid. Okay. So again, we are going to draw a line between the single oxygen and the carbonyl because this was the alcohol, this will become the alcohol. So my hydrogen is going to attach to the alcohol. So I will have, and I'm going to write this a little backwards to the way we usually show this, but I'm going to use the same colors. So we have the hydrogen, and then the rest of this is the alcohol. So we have reformed or formed, however you look at it, propyl alcohol. Oh, that's the common name. This would be 1-propanol. Okay. And then the OH group from water is going to connect to the carbonyl carbon, reforming a carboxylic acid. So we have the benzene ring, the carbonyl, and then we have our OH group, which came from water. So we've reformed benzoic acid. All right, so this is kind of an interesting application question. So the question asks us what products are formed when both esters and the addictive drug cocaine are hydrolyzed in aqueous acid. All right, as we may or may not know, based on how many movies we've watched on cocaine, cocaine is obtained from the leaves of the cocoa plant. All right, so if we were to hydrolyze these ester bonds, okay, this is an ester bond, we'd hydrolyze here. This would become a carboxylic acid again, okay? So this would form benzoic acid. And if we hydrolyzed here, we are going to form methanol, the alcohol. The rest of it is a little more complex and not within the scope of this course.